So dear students, welcome to our class. So this is a mathematics class for your JEE mains examinations. So you know that you are going to write your examination JEE mains from June 20 to 29. So the exam is going to start from June 20th and hardly there are only 10 days left. Okay, so I hope that you are all preparing well for this examination. In this preparation, I want to start a chapter permutations and combinations. Majority of the students, they will feel somewhat difficult in solving the problems of permutations and combinations and probability. Okay, I will take up the class from permutations and combinations. I will discuss a few problems from this chapter. These questions are already asked in previous problems. So just you observe that how I am solving these problems, what is the problem solving techniques and what are the short tricks that we can apply to solve these problems. Okay, now shall we start our class? So let us start our class. So dear students, let us take the first problem. This problem is asked in 2021 JEE mains examination. Okay, that means it is already asked question. Okay, then first read the problem. First try to understand the problem. The problem is a scientific committee is to be formed from 6 Indians and 8 foreigners. So altogether 6 Indians are there, 8 foreigners are there, which includes at least 2 Indians. So there should be a committee. In that committee at least 2 Indians should be there and double the number of foreigners as Indians. Okay, this is the whole problem is lies in that line only. What is that question? At least 2 Indians and double the number of foreigners. That is the main key sentence in that problem. At least 2 Indians and double the number of foreigners. Okay, then the number of ways a committee can be formed is. Then how many combinations we will get? This type of combinations I will get. Okay, now let us see that. So options are also given as A, B, C, D. A is 1635, B is 1645, C is 1625, D is 1615. So let us solve this problem. So solution, right. So here I will explain the total solution in detailed way. So in your main examinations, you no need to write all step by step. You no need to write down. You can go away in a direct answers. You can go. Okay. So here total Indians are how many? Indians are 6. Foreigners are how many? Foreigners are 8 members are there. So you have to form a committee consisting of at least 2 Indians. Okay, let us say that I will take a tabular form. I will take, so let it be Indians, there are 6. Let it be foreigners. Foreigners, there are 8 members are there. So there are number of ways. This is number of ways. Let us see that answer. Okay. So in the first one, at least 2 Indians. Now I will start with 2 Indians. The next what is given? Double the number of foreigners. That means if there are 2 Indians are there, how many foreigners should be there? 4 foreigners should be there. Okay, now okay, afterwards we will tell this. Next we will see the different possibilities we will get. If there are 3 Indians are there, how many foreigners should be there? Double means 6. Is it possible? From 8 foreigners, you can select 6 foreigners easily. Right. If there are 4 foreigners are there, Indians are there, how many foreigners should be there? 8 foreigners should be there. Is it possible to get 8 foreigners out of these 8 foreigners? Yes, easily you can select. Okay. First, suppose if I take 5 Indians, what you will get? How many foreigners you have to select? Double means how much? What is the double of 5? 10. Is it possible? Is it possible to select 8 foreigners from 10 foreigners from 8 foreigners? No, not at all possible. So this case will be not applicable, and only first case, second case, third case will be our answers. Now coming to number of ways, as we know that we have the formula, the number of ways of selecting r distinct items from n distinct items is given by the formula NCR. Okay, so where r is less than or equal to n, we know the condition. So here also 2 Indians can be selected from 6 Indians in how many ways? 6C2 ways. Okay, now right. 4 foreigners can be selected from 8 foreigners in how many ways? 8C4 ways. Okay, right. Here in these 2 values we have to put it into a plus r. That is the question here. So we have to keep into. Why? Because in this committee both Indians should be there and foreigners also should be there. So Indians should be there and foreigners also should be there. And means what? And means what? Already in the chapters you learned the principle of counting. There are 2 principles are there, addition principle and multiplication principle. Whenever we have to take compulsorily both the things, then we have to keep the concept into, right. Here also, out of 6 Indians, 3 Indians can be selected in how many ways? 6C3 into, from out of 8 foreigners, 6 foreigners can be selected in how many ways? 8C6 ways, right. Next one, out of 6 Indians, 4 Indians can be selected in how many ways? 6C4 ways. Okay, now out of 8 foreigners, total 8 foreigners can be selected in how many ways? 8C8 ways. 8C8 ways. Okay, now right. Yes, it already we know that it is not possible. Why? Already here only 8 foreigners are there. Out of 8 foreigners, 10 foreigners you cannot select. Okay, now calculate these values. Okay, now so right, see here 6C2 value 8 into 8C4 value. So 6C2 value you can find out as 6C2 value 6 into 5 by 1 into 2. So 2 1s are 2 3s are, this is a 15 into 8C4 value. 8C4 value, that is 8 into 7 into 6 into 5 by 1 into 2 into 3 into 4. Okay, now right. So 2 3s are 6 will get cancelled, 4 1s are 4 2s are 2 5s are 10, this is equal to 70. Okay, right. 15 times 70 is how much? 1050. Okay, good. So now coming to 6C3 value and 8C6 value, I am going to find out. Now 6C3 value. 6C3 value is equal to 6 into 5 into 4 by 1 into 2 into 3. 2 3s are 6, 6 gets cancelled, 5 4s are 20. Times, what is the value of 8C6? 8C6 is equal to 8 into 7. So 8C6 and 8C2 value both are same. 8C6 value and 8C2 value both are same. 6 plus 2, 8. So this is 8C2 value is given by 8 into 7 into by 1 into 2. Right. So 2 1s are 2 4s are 4 7s are 28. So this is 28, altogether 560. Okay, now right. Coming to 6C4. 6C4 value, 6C2 value both are same. Why? 4 plus 2 is equal to 6. 6C4 value is equal to how much? 15 into 8C8 value is how much? 1. This is equal to 1. 15 ones are 15. Total number of ways. That means you have to add all these ways. Here also we are applying principle of addition. Okay, so in this combination you will get 1050 ways you can form a committee. In this combination, that is 3 Indians, 6 foreigners, Like that you can form 560 ways you can form the committee, and in this combination, that means 4 Indians and 8 foreigners, you can form the committee in 15 ways. Okay, now, so all together, if you add it, 5 plus 0 plus 1, so this is equal to 1625. If you add 1050 plus 560 plus 15, this is 1625. So our answer is 1625. So you can form a committee in 1625 ways. Understand? I hope that you understand this concept very easily. A very easy problem this is, and I think everybody will answer this question. Okay, so let us go for next problem. So dear students, in this today's class, so let us start our second problem. This question is also asked in previous 2021 JEE mains examination in mathematics. Okay, let us read the problem first, try to understand the problem. Okay, next one. The students S1, S2, S3, so on, S10. So altogether 10 students are there. 10 students are there. Are to be divided into 3 groups, A, B and C. So there are competitions are there. In that competitions, these 10 students are divided into 3 groups, 3 sections, A, B, C. So there should be compulsory, there will be a condition. Then what is the condition? That each group has at least 1 student and the group C has at most 3 students. This is the key sentence. This is the key sentence in our problem. Okay, each group has at least 1 student. Each group has at least 1 student, and the group C has at most 3 students. The group C, the condition on group C is it should has at most 3 students, at most maximum 3 students. That either 1 student or 2 students or 3 students. To do this problem, we should know a formula from the chapter functions. Okay, so I will explain that formula. If you know that formula, the solution of this problem will be appears to be very easy one. Okay, so what is the formula is, see the solution. There is a 2 sets are there, non-empty sets A and B. The set has n elements, and the set B has 2 elements, x and y. There is a function from A to B. There is a function f is defined from A to B. So then how many number of onto functions from A to B? Number of onto functions. You know that onto functions means, that means that every element of B is the image of at least 1 element of A, that is onto function. So the number of onto functions from A to B is, the formula is 2 to the power of n minus 2. 2 to the power of n minus 2. That means 2 to the power of n is total number of functions. From this there will be 2 functions which are not onto. That means if you add, if you map all the elements to the element x, that is not an onto function. If you map all the elements of A to y, that is not an onto function. Therefore, out of total number of functions are 2 power n, there will be 2 functions which are not onto. That's why we are subtracting 2 from total number of functions. Therefore, total number of onto functions from A to B is equal to how much? 2 power n minus 2. Okay, now, so if you know this formula well, you can go for the solution of this. So let us go for the solution of this problem. So let us take the problem solution. So dear students, now coming to our main problem. So you know that number of onto functions. Now coming to our problem, so let us take in the first set there are 10 students are there, that is S1, S2, so on, S10 students are there. In the set, let us say this set is X and set is Y. In the set there are 3 students, 3 groups are there, A, B, C. Okay, let us see that how many possible cases will come. First case 1. See the condition on C. See the condition on C. What is that condition? The group C has at most 3 students. The group C has at most 3 students means what? The group C will have 1 student, the group C may have 2 students, the group C may have 3 students, but group C cannot have more than 3 students. At most, maximum it can allotted, only maximum 3 students can be allotted to the group C, maybe 1. So, first case we will take that, let group C have group C have 1 student. Group C has 1 student, right. Total number of students are how many here? Total number of students are how many here? 10 students are here. The group C can, these 10 students can be selected and allotted to C in how many ways? So, S1 can be allotted to C, the second student can be allotted to section C, group C. Like that, there will be 10 possible cases. So, this is equal to 10C1. Okay, now, let us take that 1 student is allotted to group C. 1 student, any 1 student, maybe S1 or maybe S2. This can be done in how many ways? 10C1 ways, that is 10 ways. Coming to B and A, it is already given that each group has at least 1 student. That means each group has at least 1 student. Means is it not the onto function? That means no group will be free. No group will be free. So, at least 1 student. So, out of already 1 student is allotted to group C. In this section, in this X set, how many students will be there remaining? 9 students will be there. These 9 students will be allotted to B and A. Is it not the onto function? Just now we have the formula 2 power n minus 2. So, this is equal to 2 power n minus 2. This is for group C and this is for group A and B. See here in between these two values whether we have to put into a plus a. So, this is also to form a committee or whatever may be that the total thing at a time it will be takes place. Okay, at a time, that means and means what? You have to take into. This is a 10C1 into 2 power n minus 2. So, if you calculate this value, you will get the value is, so afterwards you calculate that 5100. You will get the value as 5100. Let us take case 2. Let us take the case 2. Let us take that group C has 2 students. Group C has 2 students. Those 2 students may be S1, S2 or second one, third one or third one, 10th one or fourth one, 8th one, whatever may be that. That means 2 students out of 10 students, 2 students can be allotted to group C in how many ways? That is 10C2 ways. 10C2 ways. Okay, now 10C2 ways. Next, if 2 students are allotted to group C, whatever may be that, let us say that S1, S2 or S2, S5. How many students remains in set X? In set X, how many students are there? 8 students are there. These 8 students will be allotted to both A and B. Allotted to A and B. Okay, they are divided into A and B. Is it not the onto function? Is it not the onto function? Yes, surely it is an onto function. So, as already I told one formula. What is the formula? 2 power n minus 2. Here n is equal to how much? 8. Why 8? Already 2 students are gone for sections group C, no? So, this is equal to 2 power 8 minus 2. So, here into a plus a into. Okay. So, this value if you calculate, you will get 11,430. 11,430. Let us take the case 3. Let us take case 3. Okay. In this case 3, group C has 2 students. Group C has 2 students. Group C has 2 students. Those 2 students may be S1, S2 or second one, third one or fourth one, 8th one, whatever may be that. The second one, third one or fourth one may be allotted to B and A. Is it not the onto function? Is it not the onto function? Yes, surely it is an onto function. So, as already I told one formula. What is the formula? 2 power n minus 2. So, this is equal to 2 power n minus 2. So, here into a plus a into. Okay. So, this value if you calculate, you will get 11,430. 11,430. has 3 students. Group C has 3 students. Group C has 3 students. That means already C has at most 3 students. That means first we have taken group C has 1 student. Second case we have taken group C has 2 students. In the third and final case, group C has 3 students. See here, there are 10 students are there. In this 10 students, the 3 students will be selected for group C in how many ways? 10C 3 ways. 10C 3 ways. Okay, now remaining after 10 students are gone, how many students will be there? Let us take S1, S2, S3 are allotted to group C. How many students will be there? 7 students. 7 students will be there. These 7 students will be allotted to B and A. Allotted to B and A. Is it not the onto function? This can be done in how many ways? Yes, already 2 power n minus 2. So this is equal to 2 power 7 minus 2. Understand? 2 power n minus 2, that is 2 power 7 n minus 2. These two things should happen simultaneously. These two things happen. That means allotment of the student to group C and allotment of the students to both B and A. Here we will apply the principle of multiplication. That's why we will multiply into. So 10C3 into 2 power 7 minus 2 value, if you calculate, this will be 15,120. 15,120. Therefore, total number of groups. Total number of groups. It is will be given by 5,100 plus 11,430 plus 15,120. If you add all these 3 values, you will get the answer as 31,650. 31,650. So, your answer is A is your correct answer. Understand that. So, I hope that so if you know the formula of onto functions. So, onto functions. So, it is a mixer problem both in functions and permutations and combinations. If you know the onto functions concept, you can easily solve this solution problem. So, I hope that you understand this solution. So, let us go for next problem. So, welcome to our class. So, let us see the third problem today's session. So, the third problem is like this. The total number of positive integral solutions xyz such that xyz is equal to 24. First, here one thing you have to observe, positive integral solution. What are positive integers? Positive integers are nothing but natural numbers. Okay, now you have to select 3 natural numbers so that their product is equal to 24. Their product is equal to 24. How many such groups you can get? Yes, anybody can say that 1 into 6 into 4, this is equal to 24. That is one group. 1 into 6 into 4, 24. Like that. Otherwise, 2 into 3 into 4, this is also 24. 2 3s are 6, 6 4s are 24. Like that, how many? So, this is one group, one combination. This is another combination. Then what will be the another combination? This is a 6 into 2 into 2, 6 2s are 12, 12 2s are 24. So, this is one combination. Understand? So, different combinations. Fourth one, so 1 into 12, 12 into 2, this is also 24. Like that. How many such combinations you will get such that the product of the 3 natural numbers is equal to 24. Understand the concept. First of all, the question is very clear, very clear. So, don't try to calculate or don't try to write like this. So, if you start writing like this, the total time will be over for this only for this problem only. Okay, don't try to do that. Okay, right. Now, coming to how to do this problem. So, to do this problem in these permutations, we have a very one formula is there, very beautiful formula. Let us take that formula. What is that formula is? For suppose you have some so on, some n laddus we have, laddus or n chocolates, whatever may be that, n laddus are there, n laddus, 10 laddus or 20 laddus are there, laddu. So here there are R students are there, R children are there, R children are there. How many children are there? R children are there. So then how many ways you can distribute these n chocolates or n laddus to these R children so that they all will get a chocolates, or at least one student also may get a chocolate, may not get chocolate, laddu. That is the main thing. So I am giving the condition, the student may get the chocolate or may not get the chocolate. That is different one thing. So this can be done in n plus r minus 1 c r minus 1. You know how many ways you can do this? N plus r minus 1 c r minus 1. So once again I am telling, there are n objects are there. These n objects can be distributed to r boxes, otherwise n identical objects, identical, same, that's why I am telling laddus, same laddus. N identical objects are distributed to R boxes, so that at least or any, I am not saying any one of the box may be empty, or two boxes may be empty, or three boxes may be empty. That is different. So this can be done in n plus r minus 1 c r minus 1. Okay, now this is the formula. So n identical objects are distributed to R boxes so that any one of the box may be empty or may not be empty. This can be done in the formula n plus r minus 1 c r minus 1. Okay, now so I hope that you understand this formula, basic formula to solve this problem. Okay, right. So if you understand this problem, this formula, we will go for our main solution. So let us go for main solution. So dear students, coming to our main solution, the total number of positive integral solutions, that is xyz, such that their product is equal to 24. First take 24. 24 can be written as a product of primes. 24 can be written as a product of primes. 2 12s are, 2 6 are, 2 3s are. So this is equal to 2 cube into 3. 2 cube into 3. Consider these xyz are boxes. xyz are boxes. xyz. So that their product is equal to 24. xyz are boxes. First take 3. 3 can be put in any one of the box. You can put 3 here or 3 here or 3 here. Any one of the box. 3 can be put in any one of the box. In how many ways? 3 ways. Clear. You can put 3 here, 3 here or 3 here. 3 ways. Coming to second one, it is what? Okay, we have put it. So for example, if you put 3 here, yes, it is 3 here, we have put here 3. Right. Coming to this 2, no? 2 cube means 2 into 2 into 2 into 2 into 2 into 3. These 3 2s are there, no? You can put here 1, here 1, here 1, no problem. Otherwise, you can put here 2 into 2, here 1, and you can put here 1, nothing, no problem. Why? 2 2s are 4, 4 3s are 12, 12 2s are 24, 24 into 1, 2. Like that also you can put. That means you can keep the box empty. Empty means don't think that it is a 0. Empty means you can put 1. Nothing. So it is not the previous formula. So here problem, here n is equal to how many? Total how many numbers are there? 1, 2, 3. N is equal to 3. In how many boxes you have to put? For how many of them you have to distribute? 3 persons, 3 students, 3 boxes you have to put, so that if any one of the box is empty, nothing wrong. So R is equal to how much here? 3. This can be done. That means 2, 2, 2 can be distributed to 3 boxes, so that any one of the box may be empty. Empty means don't think that here 1 should be there. Okay, can be empty. This can be written as n plus r minus 1 c r minus 1. Here n is also 3, that means only 3 items are there, that is 3 plus 3 minus 1 c 3 minus 1. So this is, so coming to the answer for this is 3 plus 3 6, 6 minus 1 5, this is equal to 5c2, as we know the value of 5c2 is 10. Now coming to final answer, the first box, any one of the box can be distributed, it can be, any one of the box can be put in a 3 ways, and the values 2, 2, 2 can be distributed in the 3 boxes in how many ways? 10 ways. Okay, now to complete this problem, all x, y, z should be, all 3 boxes should be filled in at a time, and this can be done in multiplication rule. So therefore, so total number of integral, of course positive integral solutions is given by, so this is 3 ways, that is 3 into 10, that is equal to 10 combinations, just like in the previous starting of the problem I wrote, no, like that of combinations, how many combinations you will get? 30 combinations you will get. Okay, now, so I hope that you understand this solution so very easily. Okay, very nice problem, this is a very nice problem. So you solve this model type of problems, are so many problems are there in your materials in the standard textbooks. I hope that you understand this solution. So let us move to next class.